I'm going to give you a talk about software analytics and where we think they're going and how CAST is trying to play into that and kind of further the ability to use data to analyze software issues, software productivity, quality, the whole thing. I mean, the embarrassing thing is that the jocks are better at this stuff than the nerds, right? I mean, they're using analytics for everything, constantly. Who they're going to play, which kind of pitcher they're going to put on for which kind of batter, right? How could the jocks ever get better than the nerds at math? I mean, this is embarrassing. So we got to get the analytics into software engineering. So right now we're in the fourth wave of software engineering, and that's enabling the possibility of analytics. The first wave, any of you with gray hair, and I see a few of you that are probably out there when I was, back in the 70s, right? It was getting too complex. We couldn't read the assembler. It was just a dang mess. And so to solve this, we invented third-generation languages, fourth-generation languages, and structured programming, so we'd at least read the code. It wasn't hieroglyphics, right? And we thought that was going to solve the problem. But all of a sudden, the applications started getting a lot bigger, and so being able to read the code wasn't enough. So the second generation came in the 80s, and that's when we invented case tools and design methods and all sorts of things to help manage the large app architectures and understand what was being done with the app. And we were all guaranteed by Datamation and other technical publications that are no longer with us that if we would only expend a couple of $1 million on case tools, we get an order of magnitude improvement in productivity, guaranteed. But by the mid-'80s, it was clear that we were only getting about 10%. That's what the data was showing, is that for all the millions of dollars we spent on case tools, we saw about a 10% improvement in productivity, and it barely justified what we were doing. So at the time I was down at MCC, the fifth generation computer research operation, down in Austin, Texas, and we just knew, look, our problem is we just need better tools, better methods, and neater languages. And we were just doing all this wild research on incredibly complex tools and really cool languages, and nobody was seeing any benefit. One guy said, look, all of you guys are wrong. You're looking in the wrong place for solving this problem, and that was Watts Humphrey. Right? So the third generation really started with Watts, and that was process. Watts said, look, none of your tools, none of your methods are going to work as long as you're putting software folks in a box. If you're giving them commitments they can't meet, and there's no control over the baselines, there's no tool, there's no language, there's no practice that's going to make the slightest bit of difference, you've made it impossible for them to work in a professional way. So Watts created the maturity framework, and he asked me to come take over his position when he wanted to retire, and we took his model and all the practices that the SEI had and created the CMM. And then that sort of the 90s was sort of rolling out various measures of process. It sort of ended, sort of the latter part of the third wave was the creation of Agile methods, saying, look, we really need to start evaluating this more often. The fact is we're not dealing with the fact customers can't understand what they want. And so that was sort of the last wave of that, was getting into Agile methods and other ways to deal with it. So that was the third wave. It had a huge impact, and lo and behold, when we could get organizations to get up to have a reasonably consistent process and good data, all of a sudden the case tools started showing their benefits. We really did start seeing a doubling and sometimes a tripling of productivity. We could see it in the data. Why? We'd gotten the chaos out of the way, and they finally had a chance to do the work in a professional way. They could use the tools and the practices and get the benefits. And that was fine. Now, this is sort of what was going on at the same time in the industry with Six Sigma, if you'll remember Six Sigma, right? And at some point, you've done as much process work as you can to get the benefits, and you need to look somewhere else. And that somewhere else, the fourth wave, is the product itself. Right? The Six Sigma folks ran out of runway. They couldn't get enough benefit out of an increasing number of projects, so they created Design for Six Sigma, to really look at the product itself and say, how do we re-architect the product or redesign it so that it's less likely to have defects and easier to manufacture? Well, and that's the fourth wave in software engineering. It's very much focused on the product itself. And so as we got into the 2000s, there was a lot of focus on things like service-oriented architectures, product line architectures, reusability, and in CAS's case, in actually measuring the product itself and bringing that kind of measurement into the software engineering process so we could look at the structure and quality of the artifact from a number of different perspectives. So that's the fourth generation. That's where we are. And that enables a whole new level of analytics when we can really start looking at the product and take serious measures of the product and start using that to continually improve the way it works so that we don't have the outages, the failures, the security breaches, and other kinds of mega million-dollar issues. Right now, we are in the era of 9-digit defects. Right? You know what a 9-digit defect is? Now, you're technical guys. You're sitting there thinking, is that bits or bytes? No, that's dollars. Right? The defects now, the big ones are in 9 digits. They're in $100 million and beyond. Target, a couple $100 million was the lowest estimate, and that's before the lawyers get involved in the lawsuits. Night trading, that was $430 million. RBS in England, the last number I saw was 175 million pounds. Right, and that was going to go higher. So we're in the area of 9-digit defects, and this stops being a software CIO issue. This is a boardroom issue. Night trading is out of business because of it. They had to be recapitalized. So that's where we are. We went through the Six Sigma in the business, right, and we focused on improving process by taking projects that had enough benefit that we could justify the ROI. We executed those, and eventually we ran out of runway. So the question is, what do we do now if we've taken the process as far as we can take it? And the answer is, after that, is the product itself, designed for Six Sigma, which is where we need to be now in software engineering. We need to be looking at the product and say, what can we do to increase its reliability, to make it easier to modify, to make the architecture more scalable, and other kinds of issues. So the bottom line is the product focus supplements what we did with process. Now, if you haven't fixed improved your process to at least some level, you're going to have a hard time taking advantage of focusing on the product. But for those who have a reasonably disciplined process, and by disciplined, I don't mean, well, we use Agile methods. Well, I heard the Jeff Sutherland, who's the creator of Scrum, at an Agile Alliance conference, the major Agile conference, a couple of years ago, saying 70% of all the companies he visits are doing Scrum Butt, not Scrum. You know what Scrum Butt is, right? We're doing Scrum, but we don't do daily stand-ups, but we don't do daily bills, but we don't, no, you're not doing Scrum. Right? Total lack of discipline. It's just we kind of using the Agile term to kind of do what we want to do and hack around and have a lot of fun. So that's an issue. Now, fourth wave measurement really begins with measurement of the product itself, right? So we want to look at the architecture. We want to look out the next level down at the architectural and coding rules, and then we want to be able to detect violations of good architectural practice and good coding practice, both at the system level and down at the code unit level, which means we can define different quality characteristics, things like reliability and maintainability and security and what have you. And by the way, the real gurus in the security world, like Bob Martin up here at MITRE, who manages the Common Weakness Enumeration, the major repository of known weaknesses in software, say there is no difference whatsoever between security and quality. It is a quality issue. Crappy code is easier to crack into. If you've got things that will probably compromise the reliability of the code, a lot of those will also compromise the security of the code and allow hackers to break in. So this is a part of the software quality issue that we've got to deal with. So I assume all of you know CAST. I hope I don't have to explain this slide. We look at an awful lot of different languages. We integrate the analysis into a picture of the entire architecture, the entire system, where we can see the data flows and the control structures, and really reintegrate this from the user interface all the way down to the data itself, and look at the whole system as an integrated system to see what kind of problems are there, and then look at these various aspects of it, like transferability, which is understandability, and robustness, which is reliability, and things of that issue. So here's the issue. You can go on the net, you can get you some freeware. It's cheap, like it's nothing, and do an analysis of your code units, and it'll tell you whether they're nicely done, nicely developed, properly constructed, and that's fine. And Developers do this constantly. They put their code in the build. They're very proud of themselves. They have elegant things. And then something happens in the build, right? So the next step then, that's sort of at the IDE level, right? The development environment, the individual development environment level. The next step then is to look across all the code within a single language, and that's what most of the commercial tools do. And you need commercial tools if you're going to look at an entire base of like Java or C++ and analyze, is this a well-constructed foundation of language across all these different components that are interacting, and that really takes something that's not typically available out on the net. So you get tools for looking at the entire Java base or C++ base or what have you. But our problem is that that ain't the way applications work today, right? The issue now is we've got all these layers are written in sometimes 4 or 5, maybe 6 different languages. They're integrated through all kinds of ways. They're working with ERP systems and drawing data from those, and maybe some old legacy COBOL system if you're in a bank. And when I talk to architects, they say, look, my problem is not that our developers can't write good code. They can. Our problems are the interactions. Because the real issue here is that there's no developer who can understand all of that. If it was all COBOL, the old guy with the gray hair kind of knew everything because it was all in COBOL, and he probably knew kicks and could get it going, right? But the problem now is it's Java. There's interacting with a SAP system with ABAP, and there's an ASP front end, and it's going down to some database, maybe Oracle or something else. There might be some C or Objective-C if it's going off and interacting with some mobile application. And so it's all these languages. No one can know all of this, and they're making assumptions about how the components work together, and some of those assumptions are wrong. And that's where the big crashes come, is wrong assumptions. Airline systems constantly crash because somebody assumed there was a timeout in the middleware, and there wasn't. And all the threads get tied up, and the system's just sitting there waiting for Godot, right? And the customers are waiting for their airline tickets, and it ain't happening. If the system didn't crash, it's just all tied up, and when they go back, if they can if they captured enough of the operational data, they can go back in and look and say, yeah, we had no timeouts, and these things were just hung up forever. So that's the kind of problem that we've got to address if we continue to go, number one, to bigger, more complex, multi-component, multi-language systems. But even worse, we're now going to what we'll call systems of systems, right? I mean, if you're a retail organization, people are coming in, they're going to your product catalog, and that's a huge system, and probably changing a lot as you put more things in and take things out, which is going to then interact with some of your financial systems if somebody wants to buy something, which is then going to interact with a system at a credit card company to validate that you're legit, which is then going to interact with some system at a FedEx or UPS or one of the other delivery systems to schedule a delivery. A system of systems, and if it doesn't work, the user gets mad and goes somewhere else, and it may not have been your problem. It could have been something screwy in their system that your system didn't anticipate. So this is the challenge now, and it's beyond anything we can do with just process or just better practices, right? We have to deal with automation. We can't deal with this problem without being able to automate a large part of the analysis of what we're doing. So we're also in the era of architecturally complex defects when we deal with systems like that. And an architecturally complex defect is a defect that is an interaction between multiple components, frequently between multiple layers of the system. Now, the research has shown that compared to the total body of defects in a body of code, there's not as many. There's typically between 8 and 10% of the defects involve multiple components, right? So most of this is single component defect, but the problem is they consume over half the effort to fix. Why? Very simple. The number of files you've got to go touch and change, and therefore you rarely get it fixed in one iteration or in one release because you fix a lot of it and then realize, oh my gosh, there was all this other stuff I've got to go fix. And so it typically is several releases before all the files get adjusted to remove the defect from the system. This is where CAS plays ball, is trying to detect these kinds of architecturally complex defects that you simply can't see when you only look at one language or a few components. But this is where a lot of the damage done in operations is, and it's certainly a huge cost factor in development, a small percentage of the defects that create a large percentage of IT cost. So there are also in here architectural hotspots. And an architectural hotspot is where an awful lot of defects run through it, some components that have a lot of these architecturally complex defects running through them. If you can identify those and remediate them, usually means rewrite them, right, then all of a sudden you have the single greatest opportunity to cut the cost and risk of your systems. And this really is the number one opportunity to go. I remember when I was working with LM Ericsson, and they went out and identified the roughly 20% of their components that were causing all their liquidated damages in operation. They rewrote them, and bingo, liquidated damages went pretty close to zero. Because these, and it not remediate them, they just said this stuff was probably written by somebody who didn't understand the application or the language or the tools and just screwed it up. And so let's just rewrite that thing. There's a lot of these in there where you typically find that kind. They didn't understand the interactions that this component had in other places or what have you. So if we can identify these by looking at where these multi-component defects are intersecting and fix those components, we have a tremendous opportunity to reduce the cost and risk of a system. Now, there's a lot of ways to do that. One of them, for those of you who have looked at this in our capability, is the propagated risk index. So if I've got a defect and it's not highly coupled to other things, right, it's probably not going to cause a whole lot of damage. It might. Right? But not as much as if I've got a defect, a violation, that's coupled through multiple components throughout the whole system. That's a defect that has unlimited opportunities to do damage, either as a cost issue for the difficulty of fixing it or as damage during operation because of the number of different things it can go have an impact on. So this is one way, and we can go in and say which component is the riskiest that we ought to go address. Another thing that we can look at, because we can see the entire system, is all the transactions from the user interface down to the code. And we can look and say which of these transactions has the most violations along the path. Let's go address that, right? Now, if that's a transaction you don't use very often, then, if it's exercised once a year, okay, it's not as risky. If it's exercised, once every 15 minutes or once every 35 seconds, then yeah, that's probably a little bit riskier path. So I can take this kind of data and I can probably build some kind of a matrix. You can do this probably in a spreadsheet, right? And I can go in and say, look, let's look at the nature of the violation, what kind of violation it is, and the severity rating. We can either take the default value from CAST, or we can put our own value on it if we disagree with their values. And then let's look at things like, right, what's the propagated risk index? How coupled is this defect into the rest of the system based on where it sits in the system and the coupling of that component across the rest of the system? And is this a high-risk transaction that it's sitting in? And the only way I'm going to know that, okay, I can kind of look at it, but I want operational data, right? If I can get some and this is where we can start integrating, and this is true analytics. Let's look at integrating some of what we see in operations with what we see in quality analysis, structural quality analysis, to start really pinpointing the high danger points in the system. And so I can start looking at the propagated risk index, the transaction risk index, and the frequency with which that transaction is executed. And I start getting some really good information, some really good analytics about where we need to go fix this from the point of view of damage to the business or possibly cost to the business and other kinds of issues. The issue came up with technical debt. The way we've defined it, if you have to fix it, it's technical debt. If you don't think you have to fix it, it's not technical debt because you're not going to pay for it later. You may learn later on there's technical debt you hadn't accounted for because you didn't think you had to fix it. But the fact is we're looking at ways to improve our formula so we get more realistic. The problem is the first time I tried to improve it and make it more realistic, it actually rose the amount of debt by a factor of 3, which we knew no one would believe. So the problem, but that's the bottom line, and it is a very good metaphor to use with the business. Technical debt is the cost I have to principal what it costs me to fix it. Right? The interest is how much we're going to waste until it gets fixed. Right? As additional cycles it's wasting on the machine, especially if we're out in the cloud. Additional time people spend with a crummy body of software trying to fix it, as opposed to working with a cleaner body of software and being much faster with it. Then there's damages. Right? Then I can go out and look at the damage done, which is a liability. So I've got liability on the debt based on if there's an outage, a security breach, and I've got an opportunity cost. right? The fact is, if we're spending money fixing this, we're not spending money building new functionality for the business. So what's the opportunity cost of this technical debt? Because we didn't do it right the first time. And all of a sudden people get more realistic of why a little bit better discipline makes a lot of sense, and not putting people in death marches to get too much out too early actually makes much more sense long term. So it's a very useful metaphor. We only want to get everything down to effort. Right? The amount of time you have to spend doing something, because I can translate that into dollars. As you heard Melinda say, we got to talk dollars to make sense to the CIO and to the business and the executive board and everyone else. So let's look at software analytics, right? And this is now, the way most people think of analytics on the business side, it's not just I've got some data, I'm going to analyze it. It's that I've got bodies of data I can pull together, right, and start seeing patterns in this data from different sources as I integrate it and learn new things. From which body of folks, from what types of folks am I making the most money and the highest profit with my retail sales, right? And issues like that. And I'm pulling together sales data and population data and other kinds of things to learn new insights. And that's what this kind of is. And we have 4 measures in software. Most organizations need this to even get started with project management. So size, effort, quality, and that's both functional and non-functional. We do the non-functional part. And some attributes, you know, what kind of system was this? What kind of customer does it serve? What kind of environment is it in? What language is it in? And those kinds of issues. And from that, we can start pulling together multiple sources of data to answer different kinds of questions. We can really look at what affects our productivity, and is that different in different environments? Because that means I've got to have a different focus for my improvement program in different environments if it's different factors that are driving. In some cases, it may be crazy clients. In other cases, it may be lack of technical support. In other cases, it may be a very complex environment that we have to fit the software into. So, we can look at how do we increase and improve our estimation equations, our equations that help us predict quality and operation, right? And I need these kinds of data to start being, historically, to start being able to improve those. So there's a number of different kinds of analyses, and these are questions executives ultimately want an answer to. Can you improve my ability to predict and select and manage my vendors? I mean, what do I need to know? I mean, they all are going to give me the lowest possible cost. But the fact is, if they're building crummy software, it's going to cost more later. So, I would love to know the turnover rate of their people, because that's going to predict if I ever get an economy of scale. Because if every year and a half it's a whole new body of people, they're always on the learning curve. There's no economy of scale. Real useful number to know if we want to really see who's the lowest cost provider. So, there's couple of things, and we talked about some of you are using it, some of you aren't using it. A lot of you have outsourced relationships, and we have a number of clients, they just write big checks. The outsourcer says, yep, it's here it is, just write us a big check. And they write a big check because they don't know how to not write a big check. They don't have the information they need to say that's not a big enough check. So go into the effort estimator and say, hold it. We can go look at the amount of work you actually did, what was modified, what was enhanced, what was added, what was changed, what was deleted, and see the actual amount of work you actually did, and knowing your hourly rates, it looks like the bill ought to be a lot lower than that, right? And so ultimately we can use, and we've actually had one of our clients dramatically reduce their billing rates because they knew, the architects knew they were being billed 10 times the amount of work actually being done. And once they had the data, all of a sudden the billing rates went down, right? So it's the ability to balance what you're paying for the work with the actual amount of work being done, because you've got the hard facts. And this is one of the issues with analytics that we can help you with. Another one is, all software developers just love to do cool stuff. Man, they're out there doing all this neat stuff, and they're all geniuses. They're the best kid their school ever created, and so they can do it better than anybody, especially those little dumb architects that keep giving us these stupid rules. I'll just do it better than that. And so you get all kinds of junk in all kinds of directions. Nothing hangs together. And so one of the things architects would like to do is use the architecture checker, which we talked about earlier. Some of you use it, some of you don't, but be able to write architectural rules to say, is this consistent with the overall architectures we're trying to drive through various parts of our portfolio? And if not, why are you guys going a funny direction? I mean, it's going to cost us more long term. Things won't hang together. Things probably won't scale very effectively, and it's just going to cost us more. So we need to enforce architectural rules. This is a way to go in and write the rules and figure out if that's going to happen. Again, it's to get everybody in line, so we're basically one company as opposed to 40 different companies. It's just a way to reduce costs through using some of the capability that the kind of analytics we have produce. So there's 4 major value streams that we've identified that the people that employ CAST seem to be benefiting from. Right? The first is to actually reduce the business risk. Let's identify the reliability problems. Let's look at the security holes. For gosh sakes, why do we still have SQL injections? And we still do, after 20 years of knowing they were the huge risk. And performance issues that lead the customers to go to other websites. And let's address those. So reducing that risk. Now, the business, to give us the actual value, has to give us numbers for what do we lose if we have an hour of downtime during peak retail hours, right? How many credit cards could they get, and what's the cost of replacing those that we're going to get sued for by Visa and MasterCard and American Express and others? And all these kinds, so that's where we have to work with the business to get the additional data we need to provide the analytics. The question for us is, what is the reduced level of risk by fixing some number of violations? Right? It's a loss function, and the analytics are how do we reduce the loss by improving the security or robustness or performance of the system. Second issue is just purely the cost, right? And productivity and cost here and quality are very much, we can't tell the difference from the data we can collect, whether it's a productivity improvement or a quality improvement or a cost, because they're very much tied up for most organizations. The biggest driver of productivity is rework. And so that, quality improvement also causes productivity improvement until you get to a very high maturity level. And so we want to be able to look at, as we reduce the complexity of the code, how much faster can people make changes, and therefore we're getting greater productivity, right? Well, the truth of the matter is what you're really going to measure is how much more stuff are we producing per hour of developer time based on whatever we did and to make improvements in the product. You're going to see all these improvements are going to come out looking like that when you actually get down to the measures. It'll look like, we're not going to fire everybody. Everybody says, well, how many developers can I get rid of? You're not going to get rid of any of them because the business won't let you, because they're screaming for more stuff. And what you want to show the business is we are now able to produce more stuff per unit of time because of the improvements we've made, and we don't have to waste all this time trying to figure out what this screwy code is doing. Another obvious advantage a lot of you are using is control of vendors, right? And that's one thing we're doing with CISQ, is trying to get you standard measures, so you have a way to standardize what's going in the contracts, so we don't have lawyers arguing over technical issues they can't possibly understand. Right? And a final one, and this is, this is one we really focus on. We've got to help executives make better decisions. We've got to give them the analytics that they need to decide, if we're going to merge with another company, whose applications do we keep? Well, at least part of that decision ought to be whose are in better shape, so they're going to be cheaper to own over time. If I'm going to acquire this company because they got a cool product that I want to add into my product mix, is that really a good product, or could I just build a better one myself in half the time at half the cost, because the product they've got is a piece of garbage? And I can't tell you the number of companies I've been in that bought companies thinking they would quickly absorb this product, and they realized once they bought it they had to completely rewrite the whole thing because they'd never done their due diligence. So those are some of the decisions. How do I allocate my resources? What are my applications going to cost over time? So that's, if I just look at the executive decision-making issue, right, there's the analytics that we want to put in the executive dashboard. And the question is, what decisions do the executives want to make? Some of those we pretty much know under different circumstances. They want to understand how their dollars are being spent. They want to understand what's absorbing, which applications are absorbing excessive amounts of cost. Are those near the end of their life or not? So there's all kinds of decisions that have to be made, right? And they're going to be put under pressure. Are you governing the way you're spending money? And if 40% of my efforts rework, and I get to stand in front of the CEO and says, you gave me $10 million to spend on IT, and I'm proud to say we flushed $4 million of it down the toilet, because it's just pure waste. It was just rework, and it has no business value or productive value. So these are the kinds of things that we want higher level analytics taken up from the code level, but that are aggregated in sensible ways so that we can express executive level issues, cost issues, business risk issues. We actually were in Italy, our Italy country manager taking us in to see one of the CEOs of one of the large financial organizations there. And we were talking about quality and productivity improvement and all this. And the guy was, thank you very much, yeah, okay. And the minute we said, we just threw out the word risk, and the guy's ears went straight up and said, you mean you can give me numbers that I can give to the corporate auditors and shut them up? I said, yeah. Yeah, you can take some of these numbers and talk about the improvement in the risk profile of your applications to the business, and the guy became a customer. So, again, an executive level use of the measures that we typically don't think about as technical folks, because it helps get the corporate auditors the numbers they've got to put in the annual report or the 10K statement or whatever. So here's an example. This is a system integrator, and this is on 30 of their applications. This was an excellent use of software analytics. They looked at, on the y-axis, right, it's a log of the ticket count they experienced during operations, and the x-axis is the maintainability index that's provided. We could have done total quality index or a number of other things, probably gotten the same result. But the bottom line is the correlation there accounted for 1/3 of all the variation in the data. That's enormous, right? There's a very high correlation, and we counted for 1/3 of the variation, which allowed them to have a predictive equation and do some analytics that say an increase in the total quality index of 0.24 cut our tickets rates and our maintenance activity by 50%. Okay, so that's the kind of analytics, because then you can start putting numbers on it, put dollars on it, put risk on it, and have a pretty significant argument to make with the business or the board or whoever else that you have to justify why we're spending the kind of money we're spending on improving the application development activity. By the way, if you're in a CMMI world, I know some of you are because you're system integrators, this is some of the best level 4 quantitative management you can do, and it'll blow the CMMI appraisers away because they don't understand this kind of stuff. I'll say privately, you don't quote me on this, I know some lead appraisers who do Wheel of Fortune appraisals, and I can tell you who I can recommend them to you. A Wheel of Fortune appraisal is where you say, Pat, I want to buy a number. I want to buy 5. So let me show you because we have this data, you can do analytics that affect your business. It allows us to do analytics of what's going on in the industry. So we're able to look across this data to get some pretty good, and this is a consistent result we've seen for the last 2 crash reports. It was just as strong in this one. When we look at insourced, in-house versus outsourced development, we see absolutely no significant difference, right? It's not that the outsourcers are better, which they wish we'd have said. It's not that the in-house guys are better, which most of the companies wish we'd have said. The fact is, we just don't, the control of quality appears to be somewhere other than who the source was. There's other factors that have a much larger sway than who was actually building the software. One of those was, in fact, the CMM level. And we had a number of companies report their level. They'd done appraisals, or even if it was internal. And what was clear on every single health factor is that level 1 organizations produce worse code. Absolutely clear. And in some cases, like reliability, robustness, and changeability, it was much worse. In fact, 75% of the scores for level 1 organizations were below the median for level 2 and 3. And the issue here, I just described it earlier. The fact is that in a level 2 environment, the thing you're trying to do is get control of commitments and get control of baseline so you don't throw your developers into chaos. Because that's when they make lots of mistakes. They're working too many hours, nights and weekends, living on carry-out pizza, and not having time to find the defects. So that, at level 2, we start cleaning that mess up, and when we do, they start building structurally better code, because this is the structural aspect. First time anybody's actually shown that the structure of the code was better as we mature the organization. Now the question is, why wasn't level 2 different from level 3? Because that move is more an organizational economy of scale move. It's getting everybody to start using the same practices so we can reduce the overall cost of development activities. More an economy of scale. The real code cleanup was when we stopped putting these guys in impossible situations. And finally, and Melinda alluded to this, we found when we looked at the methods they were using it for the organizations that reported their methods, that people using a mix of Agile and Waterfall performed better than Agile or Waterfall. Consistently using no method was worse. They were just kind of hacking around having fun. And we didn't find a difference between Agile and Waterfall, which kind of surprised us. But the folks that were using the combination consistently produced better code. And again, for robustness and changeability, it was dramatically better. It was, again, 3/4 of the scores for the mix were higher than the median score for either Agile or Waterfall. Now, why? You know, the best explanation we've got, and it makes sense, consistent with what a lot of the gurus are saying, is that when you start adjusting your methods to the challenge you're facing, you get the advantage of upfront architectural analysis, so you don't create these huge architectural mistakes that are incredibly expensive to try to refactor later on, with the advantage of continual evaluation of the code as you're building and integrating it. So you get the best of both worlds. You get two different looks at the quality of what you're producing. You get an architectural look and the continuing structural look as you're going along. And that seems to be the best. And you know, Scott Ambler, Dean Leffingwell, Alistair Coburn, all the gurus in that world have been saying this for a long time. We now finally have data to say, yep, they were right. That in fact, because these are large business critical applications, the average here was around 400,000 lines of code. So this is not small stuff. They're business critical. For those kinds of applications, the mix is clearly better because it adjusts the amount of discipline in the quality aspects of the project to the challenge and technical challenge that you're facing as you try to build a more complex, larger application. So I'll end it with giving you a short description of CISQ and where we are, the Consortium for IT Software Quality. We were chartered several years ago to begin building standards through the Object Management Group for the structural measures you can take on code, size and quality, and then things that you'd build on top of those measures. SEI was a co-sponsor because they were being asked to do the same sort of thing. We started with 24 companies. It's now, we're in a more traditional OMG sponsorship domain where right now we've got Huawei, Wipro, and Caster sponsors. Accenture has promised that they have a check in the mail. So they'll soon be a sponsor. There's others that are joining. We've got a couple of companies in India that have said that. Somebody's laughing about that. That's sorry. So at any rate, and everyone else can join for free, and I'll show you how to in a minute. Where are we? When we started out, we had executive forums in Washington, D.C., Frankfurt, and Bangalore. And out of all three of those, consistently, the first set of measures they wanted were a measure of functional size based on the IFPUG counting rules. So function points a la IFPUG. So that's for the reason it's red, it's finished. That's now an OMG standard. We completed the work. David Heron of the David Consulting Group led that effort. So he's one of the gurus in that world. It's now available. CAS has implemented it. Others will probably implement it soon if they can analyze the whole system. But that's now an official OMG standard, and you can use it as a standard. Then there are other four. Security, I believe, OMG has a very elaborate process, but we just went through the review period. We did not get any comments. So right now it appears it is a standard. That'll get finalized in December, and we'll have the other three being submitted for their initial review process in December. So it's possible, with luck and you know, a rabbit's foot, that by maybe March we might have these through approved as standards. If not, it'll probably be June. But they're now going through, which means we're now setting up to work on the next set of standards to go through this process, which will be a formal measure, a formal definition of how to measure the various components of technical debt and how to use the measure of technical debt to adjust productivity. So we now have a measure of quality adjusted productivity, and then how we create a measure of enhancement function points, because we now need to move to the sort of the enhancement modification world, maintenance world, with the use of function points, and we need a standard for how to take the initial IFPUG definition and modify that using the concepts of enhancement function points to get an automatable measure. So that's where we're headed now over the next year. If you want to be a part of defining those measures, become a sponsor. And we'd love to have you and have your technical people jump in with us. If you can't become a sponsor, then just join CISQ. The membership is free. There's a website. And we've got over 1,000 people that have joined it. I will, from time to time, as we start these new measurement activities, ask questions about what you think about different ways of defining things like technical debt or enhancement function points or what have you. And we will take the input we get from members, but only the sponsors are going to be able to actually do the work to define what the measures are. So I encourage you to at least be a member, and if you want to be involved in defining the measure, please become a sponsor. But we are going to try to help solve the problem of, everybody's got their own definition of a measure, and therefore the outsourcers are saying, I can't deal in our contracts with 75 different customers giving us 75 different definitions of reliability or maintainability. We need an international standard. CISQ is now doing that, and very shortly you'll have those available to you for use. And they're free and open for anybody in the world to use. That's the OMG requirement, is that all standards are available to everybody at no cost compared to what ISO does. ISO is working on similar standards, but I'm on those committees. They will never get down to the level of measuring at the source code. That's just become absolutely clear. So we will supplement ISO. We're using them at a high level for definitions, but we're taking this down to the source code so you can measure it with tools like CAST to really now use this as part of an analytics framework. So thank you, and let me open it to questions.